If you are starting to notice that your vehicle is consuming more fuel than usual, and you want to learn the 3 main causes that can generate this problem, in this video, we will explain the diagnostic tests you can perform step by step to correctly solve this issue. So do not miss this video. But before we begin, do not forget to subscribe to the channel and activate the notification bell so YouTube can notify you when we upload a new video. Now, without further delay, let's get started. The main causes of excessive fuel consumption are faulty oxygen sensor. The oxygen sensor is responsible for monitoring whether the air-fuel mixture is correct. It does this by measuring the oxygen concentration in the exhaust gases. If the sensor detects that the mixture is incorrect, it sends a signal to the engine control unit, ECU, so it can adjust the mixture by increasing or decreasing fuel injection as required. However, if this sensor fails, it may cause the ECU to inject more fuel than necessary because the sensor can send incorrect signals indicating a lean mixture. This results in excessive fuel injection and increased fuel consumption. Electrical tests of the oxygen sensor. For proper operation, this sensor generally has 4 circuits: a 12-volt supply, sensor ground, heater control ground, and signal output. One of the most common failures is the absence of 12-volt power supply, which is protected by a fuse. To solve this issue, inspect the fuses. If a blown fuse is found, replace it. If no blown fuse is present, damaged wiring is very likely and must be repaired using the electrical wiring diagram. Another common failure is the absence of sensor ground. To verify ground, set your multimeter to continuity mode. Place one probe on chassis ground and the other on the sensor ground terminal. You should observe continuity. This confirms that the sensor ground is present. If continuity is not present, damaged wiring is very likely and must be repaired. Check the heater control ground. Unlike the sensor ground, this ground is pulsed and controlled by an electronic circuit inside the ECU. This signal must be measured using an oscilloscope with the engine running. The waveform should be a square wave. If no square wave is observed, there may be an open circuit or damaged wiring, which must be repaired. To measure the sensor signal output, use a multimeter set to the 2-volt DC scale and measure the output voltage with the engine running. You should observe an oscillating signal between 100 millivolts and 900 millivolts, which indicates correct sensor operation. If the signal does not oscillate, the sensor is very likely defective and must be replaced. A more effective way to check the signal is by using an automotive scan tool and observing the live data. You should see the signal oscillating between 100 millivolts and 900 millivolts. If no oscillation is present, the sensor is faulty and must be replaced. Dirty fuel injectors. Fuel injectors are one of the main causes of excessive fuel consumption because when they are dirty, they can inject more fuel than commanded by the ECU. This occurs because the injector may have poor atomization or may remain partially open, causing uncontrolled fuel delivery. To diagnose this condition, remove the injector rail while keeping the injectors connected electrically. Turn the ignition key to the on position several times without starting the engine. If you observe any injector leaking or dripping fuel, that injector is faulty and must be replaced or cleaned using ultrasonically. For a more accurate diagnosis, send the injectors to a laboratory flow test bench to verify their fuel flow rate. If one injector delivers more fuel than the others, that injector is defective and must be cleaned ultrasonically or replaced. Faulty fuel pressure regulator. This component regulates the pressure supplied by the fuel pump to the injector rail. When this component fails, the injectors can deliver more fuel than normal, causing excessive fuel consumption. The fuel pressure regulator is usually mounted on the injector rail and connected to the intake manifold through a vacuum hose. To test the regulator, connect a fuel pressure gauge to the injector rail and start the engine. You should observe fuel pressure between 35 psi and 60 psi, depending on the vehicle model. Next, disconnect the vacuum hose from the fuel pressure regulator. You should observe an increase in fuel pressure when the hose is disconnected, and a decrease when it is reconnected. This indicates that the fuel pressure regulator is operating correctly. If the pressure does not increase when the vacuum hose is disconnected and does not decrease when it is reconnected, the fuel pressure regulator is faulty and must be replaced. I recommend watching the videos on this channel where you will learn how to identify sensor failures and their solutions in your vehicle.